So now we will solve question number 8. So in this question, the straight line L has equation y is equals to k times 2x minus 1, where k is a constant, and the curve C has equation y equals to x squared plus 2x plus 11. Find the set of values of k for which the line does not cross or touch C. So basically, there's no intersection point of intersection for this two curve. So first we will assume that these two curve cut each other or intersect each other. So that's why we will find y equals to y. So that is x squared plus 2x plus 11 is equals to k into 2x minus 1. So this is basically x squared plus 2x plus 11 is equals to 2kx minus k. So we will take the entire equation in one side. So that gives us x squared plus 2x minus 2kx plus 11 plus k is equals to 0. So now let's simplify it. So we get x squared plus 2 plus 2k, 2 minus 2k, 2 minus 2k, x plus 11 plus k is equals to 0. Now understand that the question already told us that they do not meet or touch. They do not cross or touch each other. So basically the solution of this quadratic equation will be imaginary or unreal, whatever you say. So the real root, there will be no real roots of this quadratic equation. So if there is no real root of this quadratic equation, then we know that the value of b square minus 4ac will be less than 0. So for imaginary roots, for unreal roots, the nature of the root will be described as b square minus 4ac less than 0. So where b is, this is b, this is c, and the coefficient of x squared, that is 1, is a. This is a, this is b, and this is c. So 2 minus 2k whole square minus 4 into 1 into 11 plus k is less than 0. So from here we get 4 minus 8k plus 4k square minus 44 minus 4k less than 0. So simplifying it, we get 4k square minus 12k minus 40 less than 0. So we can also simplify it by taking 4 common and then eliminating it. So we get k square minus 3k minus 10 less than 0. So in order to find the set of values of k, first we will find the critical values of this inequality. So let k square minus 3k minus 10 is equals to 0. So from here we find the value of k to be minus 2 and 5. Minus 2 and 5. So let's draw a x-axis. So this is minus 2 and this is 5. And the coefficient of k square is positive, so it will be a minimum curve. So we just drew this curve. Okay, and now understand that this the portion of the graph have to be less than 0. We have to take a set of values of k for which the curve is less than 0. So this is y equals to 0 line. So it has to be, the curve has to be beneath y equals to 0 line. So if you look at this part of the graph is basically below y equals to 0. So for this part of the graph, the value of k needs to be greater than minus 2 and less than 5. For the graph to be this, the value of k needs to be greater than minus 2 and less than 5. So therefore, set of values of k has to be greater than -2 and less than 5.